Hello and welcome everybody. In this video we're going to look at solving quadratic equations using the square root method. Alright, before we get into solving, let's look at some basics. So the first thing I want to talk about is just explaining to you that this is another method to solve a quadratic, which again means determine the x-intercepts without graphing. So we have the graphing method, we have the factoring method. Here's another method, the square root method. The solutions can be called roots due to the fact that we use square roots to solve. So sometimes people say determine the roots, which really means find those x-intercepts, and it just alludes to the fact that we're using the square root property. Third thing, use the square root method when there is no linear term in the quadratic equation. So what does that mean? Well, if you look at this quadratic that I've presented here, ax squared plus bx plus c, you can see in red that we call that the quadratic term. The ax squared, the bx, which I highlighted in blue, we call that the linear term, and then the c term we call the constant. So we would use the square root method when there is no linear term. So for example, when we have x squared minus 16, so we have the quadratic term and the constant. 4y squared minus 25, same thing. We have the quadratic term and the constant. And then something kind of crazy looking likely to you right now, x plus 5 squared minus 12. So we have something squared, so it's quadratic. We don't just have an x plus 5 to the first power. That would be the linear, so we don't have that. And then negative 12 is the constant. So again, we could solve something like that as well. A non-example, so x squared plus 5x plus 4. And the reason for that is, right here. Right here. Sorry, you guys, my pen wasn't working for a second. That 5x, that's a linear term. We don't want it. Yeah, so make sure we use the square root method when there is no linear term. All right, square root property itself. So a couple details about it. Squared numbers, or just a reminder here, squared numbers and square roots are opposite operations. So they can be used to cancel each other out. All right, so if we look at this example here, if I have x squared equals 9, well, if I want to get rid of x squared, I simply take the square root of x squared. Now, what you do to one side, you have to do to the other. We got to make sure we have a balanced equation. So then now I would just have x, and that would equal plus or minus 3. Okay. The second thing I was going to mention actually is simply regards to plus or minus. We have to put in a plus or minus 3 anytime you bring a square root into an equation. Why? Because we're saying that both answers could work. We could say, well, the first answer could just be positive 3, or our second answer could be negative 3. And we combine that and just write plus or minus 3, because 3 times 3 is 9, and negative 3 times negative 3 is also 9. So both of those numbers work. All right, now the other way, I have a radical. So the square root of x is equal to 5. Well, to get rid of the radical, we have to do the opposite. That's square it. So I would square both sides. Now the reason again I'm squaring is because I have a square root. So they will cancel each other out. And then I'm left with an x equals 25. 5 squared is 25. So if you have a square root, you square it to get rid of it. If you have something squared, you square root it to get rid of the squared. And again, here's that thing I mentioned about the plus or minus. You must be sure to include a plus or minus sign when you apply the square root property to an equation that did not have a square root sign in it initially. Again, I'll give you a quick example here, x squared plus 2. So first of all, I'd have to isolate my squared term, and this is actually, I'm showing you how to solve something right now, a quadratic with square root method. Then I'd have x squared equals 4. I want x, not x squared, so I take the square root. So x would equal plus or minus 2, because negative 2 times well, actually, let me just show you instead. So if I go back to my original, I'd have x squared plus 2 equals 6. So if I say that's negative 2, I'd get 4 plus 2 equals 6. So we know that negative 2 works out. Check it again. But now I have positive 2. So positive 2 squared is 4 plus 2 equals 6. And then you can see negative 2 and positive 2 both are correct answers. So that's why we need to bring in the plus or minus sign whenever we bring in a square root. Okay, so let's solve some quadratic equations. So please notice an A here, x squared minus 81 equals 0. X squared is your quadratic term, negative 81 is your constant. There is no linear term, so this is a great chance to use the square root method. So first thing we always do is isolate your squared term. So the squared term can look different ways, but this is basically x squared. I want to get it by itself. So I can move the 81. I move it by doing that. And whatever I do to one side, I have to do the other. So I have x squared equals 81, but I want x on x squared, so I take the square root. X equals plus or minus 9. Now, another thing, solution set. These squiggly brackets. It's good to put your final answer in your solution set. So I'll have x equals positive 9 or negative 9, and then I have written in a solution set as well. I could also write it. Oh, geez, my stylus is acting funny, guys. Sorry about that. I could also write it as negative 9 and positive 9. So all that is the same. All right. Okay, so B. Same thing. I want to isolate my squared term. Okay, now, so first of all, I'm going to isolate the 25x squared, but eventually I just want to get the x squared by itself. Okay, but first things first, we have to get the 25x squared isolated. So I always move the constant away. How you move the constant? By performing the opposite operation. It's negative 49, so I'm going to add 49. $25x squared equals 49. Take the square root. Oh, sorry, I could take the square root there. I don't want to though. What I'm going to end up doing, I'm just going to scratch that out. I forgot. I'm going to focus in on my x squared. So to get rid of the 25, it's 25 times x squared. So then I have to divide. So I get x squared equals 49 over 25. Now that won't divide in nicely, so I'm going to just leave it as a fraction like that. And then I will take the square root of both sides to get rid of my x squared. So I'm going to have x equals plus or minus, and then you end up just taking the square root of the top and the bottom. So the square root of 49 is 7, square root of 25 is 5. That's my answer. Again, I could write it as plus or minus, or I could write it as negative 7 over 5 and positive 7 over 5, whatever you wish to do, guys. C, 3x squared minus 36 equals 0. Again, I'll isolate my 3x squared to begin, but I'm really chasing just the x squared. So first move is to move that constant. So plus 36, plus 36. Now I have 3x squared equals 36. I want x squared by itself, and not 3x squared. So I divide by whatever's in front of the x squared, which is a 3 this time. So I get x squared equals 12. Then take the square root. X equals plus or minus. Hopefully you remember how to reduce radicals. I'll use the perfect square method. So I'm looking for a perfect square that has a factor of 12. 4 would fit the bill. 4 times 3 equals 12. So it looks different, but that still means root 12. And then I take the square root of the perfect square. So I end up taking the square root of the 4. So my answer turns into plus or minus 2 root 3. Again, the 2 comes from the square root of 4. And I can't take the square root of 3, so that's why I'm stuck with it. So my answer is plus or minus 2 root 3. Darn pen, you guys. I'm having issues with this thing. There we go. Scribble that out. All right, D. You know what to do by now. First thing we're going to do is move that coefficient, or sorry, the constant. So I'm going to subtract 18. So I always perform the opposite operation. 2x squared equals negative 18. Now I want to get the x squared by itself, so I end up dividing by 2. So x squared equals negative 9. Then want to get rid of the squared term. I want just x, so I take the square root, And hopefully you notice a bit of an issue here. We can't take the square root of a negative number. Can't do it. Why? Because there is no number times by itself that'll equal -9. So there is no answer in this case. Now, if there's no answer, you can write it a couple different ways. The first thing we can do is just have the empty set. All right, so the first, as I was saying, the empty set, which will look like that, that's the best way to do it. If you even write no answer, I mean, I won't mind, but really that's what we're going to do. Now, what that means visually, remember that we have we're talking about parabolas, and that these answers are really just the x-intercepts. So what it means is just that we have a parabola that never has any x-intercepts. So maybe it looks like that, or like that, but that's what's going on. So it's nothing wrong, it's just this parabola doesn't cross the x-axis. Okay guys, last example, 2x minus 1 squared minus 25 equals 0. All right, first thing to point out is we have 2x minus 1 squared. That's a quadratic term. -25, that's our constant term, so there is no linear term. What would a linear term look like in this example? Well, it'd look like just in brackets 2x minus 1 to the first power. We don't have that, meaning square root method would be a great thing to try. So I add 25, add 25. So now I have 2x minus 1 squared equals 25. All right, we have our square term isolated, meaning now I can apply the square root to both sides. I then have 2x minus 1 equals plus or minus 5. So this means 2x minus 1 equals -5, and 2x minus 1 can also equal positive 5. So we're going to actually split it up and solve both cases. So I'll have 2x minus 1. Sorry guys, my pen just for some reason is not working. There we go. And 2x minus 1 equals positive 5. And then now what we have are just linear equations. So these are the types of equations you guys have solved in grade 6, 7, 8, 9. Follow the same rules. I'm going to move my constant away from my x terms, meaning I'm going to add 1 over. Sorry about going red here. So then I have 2x equals, in this case, -4. Divide by 2, divide by 2. X can equal -2. On this side, I get 2x equals 6. Divide by 2, divide by 2, divide by whatever's in front of that x. X can equal 3. And those are my answers. Those are my roots, my x-intercepts. So make sure we write our answer in the solution set. I always like to go smallest to biggest. That's why I put the negative first. And yeah, there we go. So even this type of example that maybe looks a bit scary isn't so bad. I lied to you. I decided to throw one more example in. So in this, again, it's that's strange looking. So we have a binomial really as my squared term. You can see it's already squared, or sorry, it's already isolated, meaning I can go straight to taking the square root. So I get q plus 4 is equal to plus or minus root 24. All right, so root 24, that's a radical. We want to simplify it. So I'm going to look for the largest perfect square that happens to be a factor of 24. Well, what are some perfect squares? Well, 4, 9, 16. 4 is going to end up being the largest one I can use. So I get q plus 4 equals plus or minus. You know what? Why don't I do this on the side? I like doing it like that. So I have 24. That's going to be 4 times 6. So 2 root 6. So I'm going to now put that back in my question. 2 root 6. I want to get q by itself. So again, once we get rid of, once we find the square root, it transforms the quadratic into a linear term, or to a linear equation. I'm going to solve for that q. I have to subtract 4, subtract 4. Reminder, and this is why I threw it in, -4 and 2 root 6 are different types of terms. They are unlike terms. So how do I finish it? I'd write -4 plus or minus 2 root 6, and that would be it. Okay, I'm not going to add them together, so it is not equal to You know, -4 plus 2, which maybe you go, it's going to be 2 root 6 or something like that. No, that's not what happens. You just leave it like that, and that might feel kind of funny, but that's what we do. So it's -4 minus 2 root 6 and -4 plus 2 root 6. Now remember, if you really wanted to, you could punch this into your calculator and you'll get some decimal answers. It's just that the decimal, it's going to be an irrational number, meaning it's going to go on forever. It'll never have a pattern. So it's just neater to leave it as a radical. So that's why we leave it as a radical. All right, so just in closing, the steps. First thing we do is isolate the squared term. Apply the square root to both sides. Complete the remaining calculations and simplify if possible. All right, I hope this video helps. If it doesn't, go talk to one of your teachers or talk to me. Have a great night.